Hello everyone. In this video we are going to use Excel to help us out with a binomial problem. So binomial probabilities is a specific scenario with discrete random variables. So let's look at our scenario. So it says Jane loves to go fishing. She has fished up in the bighorn so much that she knows that for any hole this time of year that she drops her fly in, she has a 64% chance of walking away with a nice trout. Assume only one trout per hole. She needs to catch fish for dinner, and she knows she can only hit 5 holes before she needs to go cook. Before she goes out, her brother says, "I bet you can't come back with more than 3. Should she take the bet?" And she only takes bets with her brother if it's at least 50-50%, like she's got a 50-50 chance. Okay, so report all probabilities and decimal accurate out to 3 places. Okay, so should she take this bet? Yes or no, and we have to answer these other questions on why. So in order to do this, let's build ourselves a probability table. So the first thing that we need to know with a binomial situation are the number of trials that we are going to do, and we have to know the probability of a specific success. All right, so let's start off with doing those two. From this example, the number of trials are the number of holes that she is going to go fish. So she is going to do a total of 5 holes. And she let us know that she has a 64% chance of any single hole of giving her a fish. Okay, so that would be 0.64 for the probability of success. Okay, now that we have this, for the binomial scenario, we now have everything given to us that we need, and we can actually build a probability table. Now, from the videos, we could actually do this by using the combinations and use factorials, and it can get kind of ugly with the equations. We're going to kind of short step that by using some of the functions in Excel. So let's start off with our table, and let's build a probability table like we've done before. So let's label our tops as X, so that's our support. We're going to do our PMF, which is the probability mass function. Alternatively, you could write it as P of the random event equaling a specific event. And then we also need to do the CDF, or the cumulative distribution function, and that is the probability of X being less than or equal to a specific member of the support. Okay, so let's do that. Okay, so now we have to think about what are all possible outcomes of Jane to go fishing. So if she were to go out and fish all of these holes, is it possible that she comes home with no fish? I'm like, yeah, totally possible. 0. Okay, is it possible that she comes home with 1? Like, sure. And if we go on this, she could come home with 2, she could come home with 3, she could come home with 4, she could come home with 5. Could she come home with 6? Now, we are assuming that she's only being able to catch 1 fish per hole. She's only going to 5 holes, so there is only a total number of 5 outcomes here. There's a total number of 5 fish in total coming. Now, the one thing that we have to remember that this is not the probability that she is coming home, that she caught a fish in the first hole, or that she caught a fish in the second hole. That's not what this is saying. This is saying that out of all of the holes that she went to, she came home with 2 fish for this line right here. And that's important to know because she could catch a fish on the first one and then miss a couple of holes and then catch a fish in the last one. So it's not saying the order is important here. It's just what's the probability that out of these 5 times that she is trying, that she has 2 successes. Okay, so in order to do our PMF, there is a handy dandy equation that we are going to use. So we're going to type equals, and we're going to type in now the binom dist, D-I-S-T. Okay, we're going to put in a parentheses, and now it says, hey, we need to put in the number of successes that we're interested in investigating, the trials, the probability, and then whether or not we're doing the cumulative or the probability mass function. Which of those are we interested in? All right, so the number here is this. This is the number of successes that I'm interested in right now. And then we put in a comma. And then it says, how many trials are you doing? It's like, well, I'm doing 5 trials. Let's go ahead and click on that. Now, for each of these lines that we're going to be checking, the number of successes is going to change, right? I'm checking the number of success 0 for this first one, and then I'll check the number 1 for the next one. I don't want this to change. But the number of trials, let me go back. The number of successes is going to change as I drag this down. But the number of trials, I don't want it to change. So I'm going to push F4 on that one to lock it. And then I'm going to hit a comma. And now I need the probability of success. Okay, I'm going to click on this guy, and I want that to be the same. So I'm going to lock it as well. I use the shortcut F4. Now, if you can't do the F4, you can always come in and just type in a $sign before the C and before the 3. Okay, and then I'm going to put a comma, and then it says, true or false, do you want this to be the cumulative mass function? And I want this to be false, F-A-L-S-E. And I can hit enter, and then, instead of having to type that all again, I can just drag this down. Now you can double check this to see if you did it right. And I can double click this, and I can say, yeah, it's checking the 5 successes out of 5 trials with a probability of success of 0.64. That's exactly what I want. Now, I'm going to go back to this one, and I'm actually going to do one more thing. So I'm going to go click on the number of trials where I have minus C6, and I'm going to push F4 again. But this is locking both the column and the row. And I actually, right now, I want it to just lock the column. Now, if what you can do is if you push your F4 repeatedly, it's going to cycle through all of the different places where it can put $signs. So this is complete lock, that cell won't move. This is the row won't move, so it'll stay on 6, but if we drag it to the right, it will shift columns. And now this one says the column won't shift if I drag it, but the rows are able to change. So what I want right now is the $sign in front of the C, but no $sign in front of the 6. All right, I'll hit enter. And what that's going to allow me to do is I'm going to drag this thing to the right now. So click here, drag it, and now I have it over. I'm going to double click on this. So now notice it's identical to this one. But now that I'm in the CDF, I'm going to get rid of this false, and I'm going to type in true. And now I have the CDF, and I'm going to drag this down all the way to my 5. And if I've done it right, the last number here should be 1. Okay, now these are like way too many decimals, so let's just practice getting a sane amount of decimals. I'm going to highlight this whole thing, and I'm going to come to number, and I'm going to push back, decrease the decimals, and let's decrease it down to 4. There we go. So now I have 4 decimals, and I can answer some of these questions. Okay, so her brother made a bet. Probability that you can't come home with more than 3. So I need to know what is the probability of our event being greater than 3. Okay, so greater than 3 here is I want to know the probability of 4 and 5. So I want to know, we could write that down, it's like the probability of x being, we could do greater than or equal to 4. That's another way we could write this down. And to do that, I'm just going to do equal to the sum of these two PMFs, right? Because that is what I'm interested in, sum up 4 and 5. And it'll give me 40%. Now, alternatively, like we saw that this is the range that I'm interested in. So that means that this is actually the range that I'm not interested in. I'll put that in red. So alternatively, I could have done 1 minus the CDF of 3, because that will give me everything that is above 3. So if I do that, check this out. It's the same thing. Super handy. So I would answer that no, she shouldn't take the bet, because the probability of catching more than 3 is equal to this 0.494. Now, the next one is what's the probability that she catches exactly 3 fish? Exactly 3 fish is right here. It's just on the PMF. It's 0.3397. We already did it. We can grab that. How many fish is Jane expected to catch if she were to do this challenge repeatedly? Okay, so we could actually like build up that column again. Remember, we had this x times the PMF of that line, x equals little x. And so we could build that column and sum it up, but Binomial has a super handy shortcut. Let's do the shortcut. The expected value of x here is going to be equal to just number of trials multiplied by the probability of success. So it says that if she were to do this repeatedly, over and over and over and over and over and over again, on average, she would come home with 3.2 fish. Okay, now we want to know what's the standard deviation of fish. Okay, again, we could build out the column, right? X minus mu squared multiplied by the specific probability of the support. We could build that column and sum it up, but guess what? There's also a handy-dandy shortcut for the variance. And once we get the variance, we can just take the standard deviation. Okay, so this one is super easy. It's, again, number of trials multiplied by the probability of success multiplied by the complement of the probability of success, or the probability of failure. So we can just do 1 minus the probability of success and hit enter. That's our variance. So our standard deviation of x is going to be equal to the square root of our variance that we just calculated. We hit enter and we get 0.107. Okay, so now we're having a given event. Okay, so probability, let's assume that our gal here, Jane, made a poor choice, that she took this bet against her better judgment. And so let's say, given that her brother won the bet, what is the probability that she caught no more than 1 fish? Okay, so the probability of x being less than or equal to 1, because that's no more than 1 fish, given that her brother won. Okay, so let's just kind of look at this red area right here. We already have determined that her brother would win in this area. And we want to know what's the probability that she has less than or equal to 1 fish, that she caught no more than 1 fish. Let's highlight those or kind of bracket them. Okay, so we want to know the probability of no more than 1, less than or equal to 1, intersect brother 1, divided by the probability of brother 1. Wow. Okay, so here let's get the probability of, okay, instead of me typing this all out again, I'm just going to copy it and paste it twice, and then I'll delete out some stuff. Okay, so for this one, that was just the brother, whoopsies. The brother winning, and this is one we want to know the intersection. Give myself just a little more space. Okay, so the probability of these intersecting is just where the box is highlighted and where the red one is true too, where they're both true at the same time. So that's just going to be equal to the sum of these two PMFs. And the probability that the brother one is just equal to, I could either sum up the PMFs or I can just grab the CDF here because that's that probability. And then if I divide the two by each other, I can just do the intersection divided by the probability of the brother winning. And there's like a 10% chance that we caught less than or equal to 1 fish, given that the brother won. Okay. Next, what is the probability that Jane catches between 1 and 4 fish inclusive? All right. One more probability statement. Probability that we have between 1 less than or equal to x, okay, and then less than or equal to 4. Okay, so this is saying what's the probability that Jane catching fish, that's a random event, is somewhere between 1 and 4 inclusive. Okay, in order to do that, all we have to do is just sum up these guys right here. We can just highlight them and sum them. Oop, I forgot to type the word sum. It's not going to do anything if I don't add the word sum. And I do that. Now, there's actually a really cool Excel thing that we can do here too. We could just say equals binom.dist.range. And then check this out. It's going to say, okay, how many trials are we dealing with? Dealing with 5 trials, comma, the probability of success, got it, the number of successes of 1, and then the number of successes 2. So I need the smaller one first, and then the bigger one. 1, comma, 4. Hit enter, and bam, it gives you the exact same answer, which is so cool that we can get this answer by just typing in the values. So, like, Excel has a ton of functionality. And what else is cool is like we can even plot this thing. Check this out. So I'm going to highlight X in our PMF, and let's go to Insert. We're going to go to these like 2D columns, but we actually need to go down to More Charts. I'm going to go down to More Charts, and I'm going to click on the one that makes it look kind of like a bell chart. So I'm going to click on this guy. I'm going to click OK. Okay, and now we have a nice little graphic of the whole thing too. And that can be helpful because now we can actually look at this thing and get some answers just from like having a graphic. Like, it is so cool and handy. Now, I'm going to show you the power of Excel. Suppose we had gone through this whole thing and we made a mistake. Suppose that instead of there being 64%, what if we fat fingered it and it was really 46? If you caught that and you were doing it in your calculator and thing, you have to go back and do all of these calculations again. But Excel is awesome. And we clicked, instead of typing in the numbers, we actually went through and clicked on cells, which gives it these like relational probabilities. So these relational, how it's doing the calculations. So if we actually delete out this probability of success and now change it to 46, everything updates, the entire thing. And so now we have all of these probabilities that have changed, and they are now updated to this new scenario. So it's cool. And even the graphic changed. Let's say it was even like 25. Look, everything changes to become updated to this new scenario. Now, the one thing that won't work is like if you change the number of trials. If you had the trials wrong, remember we'd have to like build another or take out some in our support column. So you actually would have to do some work there. But like this is super cool that we can do it just like this. And let's check our last answer is 88%, and that's what we got here. So anyhow, that's how we can use Excel to answer these binomial probabilities. We can get a graphic, we can do our CDF. There's so many things that we can do. Now, one other thing that we can do is that, like, let's say that we wanted to do a PMF or a graph also of our CDF. Like, we can do that too. I'm going to highlight this column and highlight this column. Now, I was able to do that because I held the button Control as I highlighted. So let me do that one more time. So I'm going to highlight this guy. Oop, let me start here. I'm going to highlight this guy, and I'm going to highlight this guy. Oop, is it going to let me do it? Let's see. Highlight. Come on. Okay. Instead, what I'm going to do is I'm going to push Shift, and I'm going to highlight this guy, grab this cell, move it over. I just switched my PMF and my CDF columns. Again, if you highlight an entire range, you hold the Shift and then you go in between the two, you can drag the whole thing and it will put it in between two columns. Super handy. So now I'm going to highlight this, Insert, again, go to your charts, More Charts, grab the CDF, click OK, and now we have a graph of the CDF. Like, these are super handy to be able to build and have. Anyhow, that's how we do this. Let's kind of make this clean again. Let's get our PMF and buy our CDF on the... No, stop that. Sorry. Let's highlight that. Drag this over in between there. Anyhow, that's how you are able to do a binomial scenario, answer all of these probability questions, and produce some graphics. Anyways, hope that you guys can do this on your own, and good luck.